In this video, I am going to solve few questions from Math Olympiad, MOEMS. Here goes the first question. In the figure, the whole number from 1 through 7 are to be placed. In this figure he is talking about per square. The sum of the numbers in the left column, the sum of the numbers in the right column, and the sum of the numbers in each diagonal are same. So sum of these numbers are to be same. What is the least possible product of the numbers across the gray row? So in this row, what is the least possible number so that the product is least possible product? So in order to find the numbers, we have to be careful that this gray row has the least possible number. We have to select digits from 1 through 7, 4, 5, 6, 7. So we can select 1, 2, 3 out of these for this gray row. So if we select 1, 2, 3 here, then we are left with 4, 5, 6 and 7. Now as per the question, this says that the sum of the digits in the first column and sum of the digits of the second column should be same. Here we have 1, here we have 3. Now we have to think of the digits available with us. So 6 and 4, you are getting 10, 6 plus 4, and 7 plus 5, you are getting again 12. So difference is 2, and as the difference is 2, that is then we can see over here, this is 1 and this is 3, so difference here is also 2. So we have to go for smaller digits here, because this is 3 is greater than these two set of numbers. So we will select 4 and 6 here and 5 and 7 here. So let us see what happens. 6, 4, 10 and 3, 13, 5, 7, 12 and 1, 13. So this is as per the question. The sum of both the columns are same. Now let us check the diagonal ones. 5 plus 6 is 12, 11 plus 2, 13, 7, 4 plus 4 is also 11, plus 2, 13. So that way this also fulfills the criteria given in the question, which means 1, 2, 3, the product of 1 through 3 is 6, and that is the least possible product in this case. If you take any other digit other than 1, 2, 3, the product won't be least possible. So that is our answer. Here goes our second question. In the following cryptography, each different letters represent a different digit in the 6-digit number. 1, 2, 3, 4, 5, 6. All are 6-digit number, 6-digit letter. If B is not equal to 0, what is the least sum possible? So we have digits to be chosen from 0, 1, 2, 3, 4, 5. 3, 3, 6, yes. And then we have to be careful that the sum is least possible, which means 100,000th place, these have to be minimum, and B cannot be 0. So next possible digit that B can get is 1. So we will take B as 1, and then Then after that we see E appears at next place. So E appears again here also. So as E appears in the beginning, we have to select E, also least possible digit. B cannot be 0, but definitely we can take E as 0. Similarly, I, which is next to B, we should take these values minimum. So we will take I as 2, A as 3, and U as, here in the butter, U as 4. Then we can take T as 5 and R as 6. The units place or tens place digits, even if they are larger, they are not, our digit has to be smaller. As you know, the sum has to be least possible. So we have to be very careful. The digits in the beginning, the letters in the beginning, we should assign the minimum possible values. We should assign the minimum possible values to that. So I have taken that special care to assign minimum values to the digits that appear at hundreds, thousands place or thousands place in a similar way. As those which are at the units place or tens place, they have been assigned greater value. That is most important point to be noted over here. So B is 1, E is 0, T we have taken as 5, and E again 0, and R is 6. Again B1, I is 2, 5, 0, 6. Again B as 1, A as 3, 5, 0, 6. Again B as 1, U as 4, I assumed U as 4, and 5, 0, 6. We have taken every possible care to assign minimum values towards the left hand side in the beginning, that is the thousands place, 10,000 place, and the digits at the end, the units place, tens place, hundreds place, they can be bigger in values. So now you just have to add them, and that will be your sum. 2, 4, 3, 7, 4, 11, 1, 51, 20, 512,024. So that is the minimum possible sum. I hope my explanation is clear. If you have doubt, you can just ask your question. And my explanation was also easy to understand. So if there is still any doubt, you can definitely ask me. Now moving to the next question. The next question, question 3, says that the first 40 odd counting numbers are written. How many times does 3 appear as a digit? Now this can be written and then assessed and counted. That is one possibility. Another way is, if you write these, then you can figure out this 31. These are all odd numbers written over here. 1, 3, 5, 7, 9, total 5. 11, 13, 15, 17, 19, total 5. So next 5, 5. Again 5, 5, and 5, and 5. So in total you have first 40 odd numbers, which is asked in the question. First 40 odd numbers. Now first 40 odd numbers. So how many times does 3 appear? That is the point to be, that is the question being asked. So you see 3 appears in the units place in this particular case, and 3 appears in the units place in this particular case, and 3 appears in this at the tens place. So count the number of 3 that appears. So 3 appears in units in tens place 5 times. 3 5 times, and 3 appears at units place 1 2 3 4 5 6 7 8 times. The total is 13 times. So answer to this question is 13 times 3 will appear in the first 40 odd counting numbers. I hope it is clear. There should not be any doubt in this. Next question. The next question that we have is a simple addition. You have to add all 3-digit numbers. So there are various ways of doing this question. You write them down like this: 642, 753, 864 and 975. One of the easiest method and fastest method that I recommend to students is the one which I am doing. You add the digits at units place, tens place, and this is hundreds place. So digits at units place, what is the sum? 5, 4, 9, 3, 12, 2, 14 and 1, 15. And then digits at tens place, 7, 6, 13, 5, 18, 4, 22, 3, 25. Sum at tens place, sum at units place, and sum at hundreds place. 9, 8, 17, 7, 24, 6, 30, and this is 35. This is at hundreds place. So 100 place digit multiply by 100, 35 times 100, that gives you 3500. Then tens place multiply by 10, that gives you 250, and 15 is at units place, so it is 15 times 1, and that is 15, and then add them 5, 6, 7 and 3, and that is your answer. Another method for the same question I would like to explain you here also. First let me add it by that method, then I will explain. 5, 4, 9, 3, 12. Subtract 10, you get 2. 2, 2 and 1, 5. Write here 5. And there is one dash, so give that dash, give 1 here. 7, 1, 8, 6, 14, 5, 9, 7, 1, 8, 6, 14. Subtract 10 and carry 5, 4, 4, 5, 9, 4, 13. Subtract 10 and carry 3, so 3, 3, 6. How many dash you have put here? 1 and 2. So give 2, write 2 here. 9 to 11 minus 10, 1, 8, 9, 8, 1, 9 and 7, 16. Subtract 10, 6, 6, 12. Subtract 10, 2 and 5, 7. And how many dashes you have put? So 1, 2 and 3. So write 3 here. So this is another method. This method also requires a little practice, but you will find at the end this is much faster. Any of the method you can go for and solve the question. I hope my explanation is clear, and if you have any question you are most welcome to ask me in the comment section. Thank you so much.